Good morning, algebra. Well, I'm not with you today, but I left you a lesson, so it'll be almost like I'm there. I miss you guys already. So here we go. We are going to jump into lesson 8.3, quadratic functions in standard form. We've already learned how to write things in standard form, but now that we're into graphing these equations, these functions, we're going to see how um, what being in standard form does for us when we graph things. So we have looked at the last couple of days graphing, going back to that first Desmos activity we did last Friday, and now seeing how the parts of the equation affect how the graphs or how the functions sit on the graph, and then we learned vertex form. And now we're going to see what standard form can do for us. So there are parts of standard form that are very, very simple. There are parts of standard form that are very versatile. I can use them in lots of different ways. And there's going to be one little tricky part to it that you just got to get your mind wrapped around the formula. It's a simple formula that we pull out of standard form, but it's going to be a little bit different. So when you first see it, you might think it's a little bit confusing, but as we do it a couple of times, hopefully it'll seem pretty simple. It really is simple. I don't want you to get worried about it. So here's what we're going to do today. We are going to graph quadratic functions in standard form and show, I think they left a word out there, in standard form, and show the intercepts, which we're going to take special note of the y-intercepts. But we're also going to notice maybe the x-intercepts a little bit in this lesson, but that's just setting us up for some future things that we're going to do with x-intercept. We're also going to notice maxima and minima. That's just the vertex. The vertex, when it's downward facing, will be a maximum. When it is upward facing, it will have a minimum. It will have a bottom point when it's upward facing. It will have a top point when it's downward facing. So we're kind of used to that already. I'm not sure if we've used those fancy words maxima and minima or not, but that's all that means, is we're going to find the vertexes. We're going to determine how the values of a, b, and c affect the graph. It's a little less obvious than with vertex form when we have those h and k values, and it's very predictable where the h and the k go. To me, it's a little less obvious with these in some ways, but I think we'll still see some relationships between those numbers and how the graph moves. We're going to identify key features of parabolas. That's kind of the same thing it says up here. We're going to show the intercepts and the maxima and minima. And compare the properties of quadratic functions presented in different forms. Every form has its strengths and weaknesses. So when we see a formula written out, there are certain things we can tell. When we have a table, those things look a little different. And then on a graph, they look a little different again. So how do each of those things work for us? All right, enough of that. Let's jump right into our little warm-up question here, just to kind of get our minds thinking about how the graphs move around, or how the functions move around the graph when we change different values. So if it's f of x equals ax squared plus bx, and then we're going to put a 2 in for a. All right, so notice that each of our functions have an a value of 2, but then we're changing the b value. So in this red one, we've got 2x squared minus 2x. Notice where it's at. We've got in the h, the blue one here, we've got 2x squared, so it's the same a value, but now our b value is negative 4 instead of negative 2. And in the green one, our b value is what changes again to negative 6. So notice what that's doing to the graph. It's not changing the shape of the graph. They're still the same shape, but it's changing the location of the vertex when I move that b value. And it's maybe, like I said, it's not as predictable. It's not as obvious to me where that vertex is ending up based on what I do with the b value. But we're going to learn how to use standard form so that it does become more predictable when finding the vertex. So what do the graphs have in common? Well, they're the same shape. They open upward, and they're just, and what's different about them? Well, they're in a different location. They have different vertices, different vertexes. Part B is kind of a similar question. What do you notice about the x-intercepts of each graph? Well, they share one x-intercept at the origin, but then because the graphs are moving, those other x-intercepts move along the x-axis. And so they share one set of x-intercepts, but they have a different other set of x-intercepts. And then what do you notice about the y-intercept? Well, the y-intercept is on the y-axis, and they all share the same y-intercept at the origin. That's going to be very important for what we're doing in the upcoming slides, noticing that y-intercept. All right. I do want you to work with Desmos some today, since you're already watching this on your computers anyway. It won't be hard just to open up another tab that has Desmos on it. That's what we'll do on this next one. So we want to relate the C value to the graphs and see how that C value plays out when we're graphing things. And so if you open up your Desmos window and type in the equation that I have given here, we can get started on that. So pause here and open up Desmos, and I'm going to jump over to it right now. So I'm assuming you've paused and that you've opened up a Desmos screen. Whoops, I already had that entered in. So if you entered in the equation that I asked you to enter in on the slides, you will have one that looks just like what I've got here. It's got negative 2x squared plus 4x, and your graph should look exactly like mine does here. And then all I want you to do is play around with adding in some C values. So, for instance, as I had just a second ago, if we put in a +3, notice what happens to that graph. And maybe what I should do is just leave that graph where it's at and add in f of x. I think there's a quicker way to do this. You guys probably remember how to do it. Negative 2x squared plus 4x. So it's the same equation, but if I add do a +3, look what happens to it. It's kind of predictable based on what we've already done. It just moves the graph up 3 notches, right? So the vertex of my original parabola was here, and if I add a +3, it goes up 1, 2, 3 units. Okay, and so that C value moves the graph in a vertical direction. And so, of course, if I did a -3, then it would have moved it down 3 units. So from here, it goes down 1, 2, 3 units. But really what I want you to notice, if you haven't already, is look at the y-intercept. Every time I move that C value, notice where the y-intercept is. The y-intercept is at 0, 2. Well, there's the y-intercept at 2. If I change that to a +5, then my y-intercept becomes 0, 5. If I change it to a -5, then now my y-intercept is at -5. Okay, so the C value is the y-intercept. It gives us the vertical translation, the vertical movement of the graph. But more specifically and more importantly for what we're doing right now with graphing is it gives us the y-intercept. So now that you have a Desmos window open, I'm fine if you're using Desmos as we move through here, because we're going to start graphing some things, and I gave you graphs on your paper that you should be able to use. And I'm perfectly fine with using Desmos as we move through and graph these things, but you do need to be able to graph these on paper as we move forward. So if you're relying completely on Desmos through the lesson and then through the assignment, and not learning how to find the parts of the equation that you need to be able to graph these and graph them on paper, then you're only hurting yourself. So I probably, well, I might be back on Desmos on one, I can't remember. Anyway, I might come back to Desmos for a slide or two later, but most of what I'm going to do, I'm just going to graph by hand. So I'm going back to the slides. And the next question in the slides here is how does f of 0 relate to the results in example 1? So the thing that we just did with a function, any given function written in standard form, if we put a 0 in for x, what's going to happen? Well, if I put a 0 in for x, I would have, get this back out here, I would have a f of 0 equals a times 0 squared plus b times 0 plus c. And so what happens here? Well, a times 0 is 0, and then I'm adding b times 0, which is 0. And so all that's left is c. So f of 0 equals c. And hopefully you remember that anytime I want to find the y-intercept, I just need to put a 0 in for x. And that's exactly what we did here. We put a 0 in for x, so my y-intercept is 0, comma, c. And that means whatever that c value is going to be my y-intercept because it's a 0 in for x. Hopefully you followed that. That's just, I mean, that goes all the way back to pre-algebra and finding the y-intercept of linear equations too. So just another way of showing, we saw it on the Desmos with the graphs. When we change the c value, it changes the y-intercept to that value. Here's why mathematically that's true, because we put a 0 in for x. All right. This, guys, this is it. This is the slide. You need to keep this one in front of you as we go through the lesson, because we're going to refer back to this slide a lot. We know how to find the vertex of a graph or a parabola when it's written in vertex form. It's already there in the equation for us. But what if it's written in standard form? How do we find the vertex? Well, here it is. This formula here, this little tiny formula, gives us the means to find the vertex when an equation is written in standard form. So f of x equals ax squared plus bx plus c. That's standard form. A cannot equal 0, because if a equals 0, it gets rid of this x squared term, and then we don't have a quadratic formula. We've got, or a quadratic equation. We've got then just a linear equation. If we get rid of the term that has this exponent, it's no longer quadratic. So a cannot be 0. The c value then is the y-intercept of the graph and the axis of symmetry. Here it is. We're going to find the axis of symmetry by using this equation. We're going to say x equals negative b over 2a. So there's our b value. There's our a value. All we got to do is plug in our b and our a into this equation, and we'll find the x value of our vertex. And once we know the x value of the vertex, then we can put that x value back into the equation, and we can solve to find the y value of our vertex and find the vertex itself. It takes a couple of steps. They're not hard steps. They're just steps. And we're going to do those steps right now and graph some equations that are given to us in standard form. Okay, so here we go. We've got our standard form equation, f of x equals 2x squared plus 4x plus 3. And so we can look at it and already know, we know what the y-intercept is. The y-intercept is 3. But that's not enough information for us to be able to graph very much. So we've got to know the vertex and a couple of points in order to graph this sucker. And so what I want you to do, what is the best thing I think to do is to find the vertex first. So we're going to find the vertex and the axis of symmetry kind of come at the same point when we use that little formula. So the formula, remember, is x equals negative b over 2a. And so all I have to do is plug in numbers. Negative b, 4, over 2 times a. So 2 times 2. So negative 4 over positive 4 is negative 1. So my axis of symmetry is on the vertical line x equals negative 1. All right, that means my vertex is on negative 1. Somewhere on this line right here is my vertex. And I just have to find the y value. I don't know if it's way down here. I don't know if it's way up here. I don't know where that vertex is until I find it. And I can find it just by plugging negative 1 back into the equation for x. If I put negative 1 into the function, that will tell me where my vertex is. So f of negative 1 equals 2 times negative 1 squared plus 4 times negative 1 plus 3. So negative 1 squared is positive 1. 2 times 1 is 2. and then this is minus 4, because 4 times negative 1 is negative 4. So it'd be 2 minus 4, that's negative 2, plus 3 would be positive 1. So f of negative 1 equals positive 1. That's my vertex. Negative 1, positive 1. Okay? Now we're going to build a little table here of some values because we want to be able to graph. And it says, I think, well, somewhere it said to find a couple of extra values. So we're going to do this. And I'm going to put my vertex here in the middle because I want my vertex to be my point of symmetry, right? So I'm going to do negative 1, 1 right here. And then I already know my y-intercept. My y-intercept is 0 for the x value. And so if we're putting x values in order here, we'd have negative 1, 0 would actually go here, right? So 0, comma 3. And let's think about that. Let's just graph those 2 points. So negative 1, positive 1 is right here. That's my vertex. And we already know, because A is positive, that it's going to be an upward facing parabola, so it's going to be U-shaped. And then my y-intercept is at 0, 3. And because this x equals negative 1 is my line of symmetry, I can put another point on the opposite side from the y-intercept. So y-intercept is here, just count it's 1 over to the line of symmetry, and then 1 on the other side of the line of symmetry. So I've got to have a point right there. And that's another point I can put on my table. 1, 2, 1, 2, 3. So negative 2, comma 3 would be an ordered pair. All right, so if I want to put another point on my graph, and this is how many I want you to do, we can put a 1 here into our table, and I can just put a 1 into my equation. So f of 1 equals 2 times 1 squared plus 4 times 1 plus 3. So that is 2 times 1 is 2, plus 4 is 6, plus 3 is 9. So f of 1 is 9. And so if I do 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, right there. And then I can use my line of symmetry. Since my line of symmetry goes down the x equals negative 1 here, I can do 1, 2, 1, 2. There's my other ordered pair. So that would be negative 3, 9. And you should be able to see the symmetry, of course, in the parabola. You should be able to, oh my goodness, this is so hard to do on this thing. As we graph the parabola, oops. Oh my gosh, that's horrible. Squiggle, squiggle, squiggle. Oh my goodness, that's so bad. Look like I have a palsy. All right. So there we go. That's the parabola. You should be able to see the symmetry, of course, in the parabola. If I could draw it correctly, you can see the symmetry. But you should be able to see the symmetry in your table of data too. Here's your vertex, and then it goes down 1 and up 2, and it goes up 1 and up 2. And then it goes up 1 and up 6, and then up 1 and up 6 here as well. So I hope you're seeing it. I can't tell if you're seeing it or not since I'm not there to see you, but hopefully it's all making sense. It seems so simple to me. All right, let's do another one. We're going to do the same steps. We're going to first find our vertex and use that vertex to find, with our line of symmetry, and use the y-intercept to get our first couple of points on there, and then add in some points as well. So vertex, I want to use x. Oops, I wanted to switch. I think the red's easier to see on the graph. I think it is. X equals negative b over 2a. So negative 2 over 2 times 1. Since there's no number in front of the x squared here, then a is 1. So that would be negative 2 over positive 2 is negative 1. Once again, we have a line of symmetry. Our axis of symmetry is going to be right here on x equals negative 1. So I've got to find where on that line of symmetry my vertex is. So all I need to do then is put negative 1 back into my equation. So I'm going to find f of negative 1 equals negative 1 squared plus 2 times negative 1 plus 4. So that would be 1 minus 2 is negative 1 plus 4 equals 3. All right, so if I start my table here, I'll move that over just a little bit so I can write on it a little more easily. X, Y, and I want my vertex in the center, so I'm going to do negative 1 comma 3 is my vertex. So negative 1, 1, 2, 3. Whoops, that's not right. Negative 1, 1, 2, 3. I don't know what I was thinking. There we go. And then my y-intercept would be on this side, so that would be 4. So 0, 1, 2, 3, 4, which means I've got another point right here at negative 2 comma 4. And then if I add in one more point, 1, so f of 1 equals 1 squared plus 2 times 1 plus 4. So that'd be 1 plus 2 is 3 plus 4 is 7, which means negative 3, 7 as well. So 1, 1, 2, 3, 4, 5, 6, 7. And this one goes up 1, 2, 3 over 1. And I'm sure that some of you have already kind of keyed in on, you know, we've been talking some about the shape of the parabola. And so since the a value is 1, this becomes a very predictable rate of increase here. It goes up 1, right 1, then up 3, right 1. The next one would be up 5, right 1, and so on. So if you're seeing that, that's fine. I still want you to build the tables of data. I think it's going to require you to do that probably in some of the assignments, and certainly on the paper assignments that we'll do for this, like the quiz next week that we'll take. I want you to build some tables because that's one of the standards that we're able to go back and forth between different representations. So a table is one of those representations. All right. One more example. This one's going to be a little different because it's got decimals. It's got downward facing parabola. Don't be scared of decimals or weird numbers. Sometimes you end up just having to graph some partial numbers in here, and that's okay. So we're going to find our vertex first. Vertex is going to be x equals negative b over 2 times a, which is negative 0.75. So that is negative 3 over negative 1.5, which is 2. So my my line of symmetry is going to be at x equals 2. And of course I have to find where on that line it's got to meet, so I'm going to put 2 in for x. F of 2 negative 0.75 times 2 squared plus 3 times 2 minus 4. 2 squared is 4, and 3/4 of 4 would be 3, so that's going to be negative 3 plus 6 would be 3, and then minus 4 would be negative 1. Guys, you can type those straight into your calculators. If you're not following what I do in just verbally there, when it comes to your homework, just type it straight into your calculators. Negative 0.75 times 2 squared plus 3 times 2 minus 4. And it'll tell you negative 1. Okay? So my vertex then, xy, that's a y, believe it or not. Y is at 2, negative 1. So over 2, down 1, right there's my vertex. I know that check out where I'm at. If I've got to go over 2 spaces to get to my y-intercept, and this time the 0 is going to be up here, right? Because I want to put a 1 there, and then I'm going to need a 3 and a 4. Okay. So the 0 is at negative 4. 1, 2, 3, 4. And then I could do 1, 2, 1, 2. So that would be at 4, negative 4. And now all I got to do is put a 1 into my equation. So negative f of 1 is negative 0.75 times 1 squared plus 3 times 1 minus 4. So that would be negative 0.75 plus 3 minus 4 would be minus 1. So negative 0.75 minus 1 equals negative 1.75. That's okay. It's okay to have a decimal. Negative 1.75. So I can go 1, negative 1.75 is about right there. And then I need to go over my line of symmetry and do it again there. So there you go. These are exceedingly difficult on this slate. Okay, there we go. All right. I know this is taking man, those are not fast. They're not fast problems. We don't get through those in like 7 seconds like you're used to on some of the things. But, and I'm probably talking way too much, sorry. But there you go. All right, let's look at some word problems. Yay! All right, the trajectory of water from fountain A is represented by the function in standard form, while the trajectory of the water from fountain B is represented by the table of values. Compare the vertex of each function. Well, looking at a table of values, can you find the vertex? You should be able to, because it should be right in the center of the symmetry. So I've got a 5 and a 5 there. I've got an 8 and an 8 there. So this one is 10. It's right in the middle. So this one for B, that has to be the symmetry, the vertex, right? So negative 4, 10 is the vertex. Think about what this graph would look like at negative 4. I'm going to have the height of 10. So if we had a little graph here, you know, and I went over negative 4, my vertex is at 10, and at negative 5, you know, one over here, it's 8 and 8, and then at negative 6, it's 5 and 5. So this thing is going, it's a downward facing, it's going like that. And so my vertex, my maximum is right here at negative 410. Okay? So what about this guy, fountain A? Fountain A, we've got to do a little work because we've got to find our vertex. So x equals negative b, which is 2, over 2 times negative 1. So negative 2 over negative 2 is a positive 1. All right. And then once I know that, then I can find f of 1 equals negative 1 squared plus 2 times 1 plus 8. So that would be 1 plus 2. Oh, wait a minute. Oh, this is, I about botched it there because that negative symbol doesn't get squared. Okay, so I was making a mistake and couldn't figure out what it was. So 1 gets squared, but the negative sign is not, it's negative whatever this is. So once we square x, we make it negative. So it's negative 1 plus 2 plus 8. So 2 plus 8 is 10, and the negative 1 would be at 9. So f of 1 is 9. So the question is, which trajectory reaches a greater height in feet? Well, if this one reaches a height, a maximum of 10, and this one reaches a maximum of 9, then B, fountain B, has to be a higher trajectory. It's got to be a bigger, a higher fountain. So it gets to a higher height. Okay. There you go. That's comparing an equation and a table. Look at what we can do. We can figure out which one of those functions produces a higher minimum, or a higher maximum. So there you go, just by looking at two different representations. What about if we have a function written as an equation and a table? Or a graph, sorry, can we compare those as well? Of course we can. So what are we're going to compare the function and the maximum values. So which function has a greater maximum value? Well, this one, we can see the maximum value. The maximum value is at 3, 0. So the highest point is at 0. That's the highest it goes. Okay, so we're always looking for the range value, the output in that case. The maximum of this function is 0. All right, well, let's find the other. We got to do a little work. So let's do x equals negative b is negative 0.6 over 2 times negative 3. So a negative negative is a positive. So that would be positive 0.6. Oops, I wrote negative. I don't know why. Let's try that again. So negative negative is positive, so it would be 0.6. And then this one would be, that's 0.3. So 2 times negative 0.3 would be negative 0.6. So positive 0.6 divided by negative 0.6 is negative 1. Negative 1 is my x value, or my line of symmetry. So that would be over here, right? And negative 1 then goes back into our function, f of x, f of negative 1 rather, equals negative 0.3 times negative 1 squared minus 0.6 times negative 1 minus 0.2. We got to keep track of the negatives this time. So this one, the negative sign does get squared, so it's negative 1 squared would be positive 1. So negative 3 times positive 1 is negative 0.3. A negative 0.6 times negative 1 would be a plus 0.6 minus 0.2. So that would actually come out to be a positive 0.1. So this one has an ordered pair of negative 1, comma, positive 0.1. So which one has the higher maximum? This one does, because it's at 0.1. So this one would actually be just a little bit above the x-axis and go down. This one was right on the x-axis and went down from there. So this one has a higher minimum, or higher maximum, sorry. All right, another word problem. Mia tosses the ball to her dog. The function f of x equals negative 0.5 times x minus 2 squared plus 8 represents the ball's path. So this is written in vertex form, which hopefully you haven't forgotten now that we've been looking at standard form. So vertex form, what does this tell us about the situation? Well, it tells us it's going to have a downward opening parabola. You can kind of see that from the graph. It tells us that the vertex, the vertex is at 2, 8. So there you go. It tells us that. Okay. And it tells us downward facing vertex. Yep, that's what it tells us. Okay, checking my notes. And then for B, it asks us, what does the standard form of the function tell us about the situation? Well, this is not written in standard form. How do I change it to standard form? It's not hard, it's just math. Okay, so I'm going to switch back to this color so we can see what I'm doing here. Oops, that's not the color. So maybe this one. I can't see it very well. All right, there we go. That'll work. All we have to do is expand this. We just need to multiply it out. Don't forget your order of operations. We do exponents first, then we do multiplication, then we do addition. So we know how to expand these squared factors, right? So f of x equals negative 0.5 times x squared minus 4x plus 4. And then I still have the plus 8 on the end. Okay? So all I did was x squared, then negative 2 times x is negative 2x, times 2 is negative 4x, and then negative 2 squared is positive 4. Okay, so that got us here. Now I need to distribute. So f of x equals negative 0.5 x squared. Negative times 0.5 times negative 4 would be plus 2x. And then negative 0.5 times a positive 4 would be minus 2. And then I still have this plus 8 on the end that I need to finish in my last step here. So f of x equals negative 0.5 x squared plus 2x plus 6. So what does the standard form tell us that the vertex form doesn't tell us? It tells us the x-intercept. Or no, sorry, the y-intercept. Said that backwards. It tells us the y-intercept. So this tells us that the y-intercept is 6. All right, there we go. Guys, this video has dragged on long enough. There's another one here where they give you basically it's the same situation. They just change, they like to do this. Same picture, same story. They just change the equation a little bit. Same steps I did on the last one, just multiply the vertex. It tells us this, the vertex is at 1, 6.25. So 1 comma 6.25, and then if you solve it out to get it in standard form, it would tell you the y-intercept. Okay, I know this has been a long video. I know some of you are gone Friday. There is an assignment to work on that I'll push out to you. Do the best you can. We'll work on it Monday, and Monday we will review for a quiz over these 3 units that we've had in Chapter 8. We're going to take that quiz on Tuesday, and Wednesday we're going to do fast bridge testing, and then after that we will start on Chapter 9. So that's the plan. Monday review, Tuesday quiz, Wednesday fast bridge, Thursday, Chapter 9 starts. I will see most of you guys tomorrow.